Hey, so I realized at almost 11 o'clock tonight that I forgot to make your video, and it is for tomorrow after your quiz, so guess what I'm doing? Anyway, I'm sitting on my couch and I'm making a video, and what more fun could it be? We're starting to talk about rational numbers. Make sure you have these notes in front of you. Make sure you filled out the name and date and the period at the top because you know you're going to have to show us these notes when you get done. And also make sure you have a calculator because we're going to use calculators a lot from now on. Rational numbers, I'm not sure if you've heard of those before, but that's what we're going to be talking about. And you probably recognize some of these phrases over here to the left side: whole numbers, natural numbers, integers, and now we're talking about rational numbers. So rational numbers is the number system that classifies numbers based on their type and characteristics. We classify things all the time. We classify shapes. We put like things together. It's the same thing here. We're putting like things together. I'm going to start with whole numbers here at the top. Whole numbers are what you learned about early on in school. It's the set of all positive counting numbers, but this starts with 0. Okay, we don't usually start counting with 0, but you learned what 0 meant. You meant nothing. For example, 0, 4, 7, 14. Those are your examples. I'm going to be going quickly through this, so if you have to pause at any point, go for it. Now, the natural numbers were the first set of numbers you learned as a little one. Natural numbers are counting numbers, but they don't start with 0 because who counts with 0? They start with all of the positive integers, obviously starting with 1. You're going to go 1, 2, 3, 4, 5. You might count to 10. You might count to 1,000, but you won't say 0. So whole numbers and natural numbers are the exact same thing, but whole numbers have a 0 in there. Natural numbers don't. Examples: 1, 2, 3, 4. Couldn't get much easier than that. Integers are the set of whole numbers and their, do you know this? So last year in 6th grade, for the first time, you had always worked only with whole numbers or maybe some fractions and decimals. But last year they introduced you to integers, which were the whole numbers and their opposites. You even put them on number lines, you put them on coordinate grids. Those included your negatives. We've been using those a lot, right? So the examples here are -5, -10, 10, 3, and -18. Now the next group we're going to talk about is something that you have seen before, but maybe not with negatives. So rational numbers can be written as fractions, terminating decimals, and repeating decimals. I don't know if you know what those are yet, but we're going to learn about those today. And the examples are, -5.6, 3/4, 3 1/6. And you've seen all of those before, but maybe not with negatives in front of them. That's the only difference. So we're going to go to the next slide here. It's on your same paper, but mine's broken up into several parts. Down below, it says determine if the fraction below is terminating or a repeating decimal. I think you have done this a little bit before, but even if you have, we're going to repeat it again. Now I want you to remember, if I have a fraction and I need to change it to a decimal, this fraction bar here means divide. You learned that in 5th grade. In 5th grade, you talked about fraction bars meaning divide. And we say it as the top number divided by the bottom number. So in this case, it's 5 divided by 6. Grab your calculator and please press into your calculator 5 divided by 6 right now. See what you get. This is what I got. And on my calculator, it said 0.833333333, and it ended there. But it only ended because my calculator ran out of space. And because 3 is a number less than 5, I didn't have to round anything. So it's just the way it is. But instead of me repeating all of the 3's over and over and over again, you just put that repeating bar on top. So perfect. So is this terminating or repeating? Well, it's terminate means to end. If you've ever seen the Terminator, it means to end. Terminating means end. This doesn't end. It repeats. So this is a repeating decimal. Try the same thing again with 2 over 11. 2 over 11 means 2 divided by 11. Put it into your calculator, please. And look at that. I have 0.18181818. It's going to fill up my calculator. It may round the very last digit to 2. The only reason it might round it to 2 is because there's an 8 next to it. So if it ends with 0.1, the next digit would have been an 8, so that rounds the 1 up to 2. That doesn't mean that it's changing digits at that point. No. It just means the calculator has run out of space. So we put a repeating bar over both the 1 and the 8 because both of those digits are repeating. And yes, it's a repeating decimal. Let's try it again with 17 over 20. 17 over 20 means 17 divided by 20. Go ahead and put it into your calculator. And you should get 0.85 or 85 hundredths. Because I can say it with place value, I know it is terminating. It means it ends. It didn't go on any more than that. Okay, make sure you have that. We're going to go on to the next slide. Well, here we go. You get to just copy this part. Label the different parts of the number system diagram below. And I want you to recognize that the smallest group of numbers that you know are whole numbers. Whole numbers are the ones you've been working with until like 3rd grade when you learned about fractions. Integers are what you learned about 6th grade and 7th grade this year, and you're going to use a lot in the future, all the way through high school. And rational numbers, you've used with fractions and decimals, but now we're throwing in negatives. So rational numbers could be positive and negative fractions and decimals. Now over here to the right, if you can see it, it says, is it possible for a number to be both a whole number and an integer? Yes, because the whole numbers are part of the integer square, or the rectangle. However, could I say that rational numbers are part of the integers? Only some of them are. If you notice, only some of the rational box. This rational box is big, and the integers are only one part of that rational box. Okay, make sure you have all of this. And I gave away the answers way too soon, so go ahead and copy first, and we're going to talk about it. To review how to add fractions, it says find a common denominator. Do you remember doing that? Find a common denominator, and then with that denominator, you're going to help rename all of the fractions. You're going to add the numerators, and then you're going to keep the denominator the same. Hopefully that rings a bell to you. Let's see if I can, there we go. So in this case, I know that the denominators are not the same. I'm going to want to change both of those to eighths. So luckily for me, this first denominator doesn't have to change. The second one does, though. And I'm going to have to talk you through it because I don't have a way to write on this right now. But if I change 1 1/8 to a fraction over, or 1 1/2 to a fraction over 8, that means I have to multiply 2 by 4 to get 8, and I have to multiply 1 by 4, and I'd get 4. When I get done adding all of those together, I'm going to get 2 3/8. Now test this on your calculator, because we're going to use our calculators all the time. Put 7/8 in there and add 1 1/2, and see if your calculator gives you 2 3/8. And if it doesn't, we need to talk about it. Now let's talk about decimals. First of all, and this was on your CR this week, if you recall, one of the questions on the CR was somebody who had added decimals incorrectly. And what they did, if you think about it, is all about what we're talking about here. It says rewrite the problem vertically, up and down, right? But when we line them up vertically, we have to make sure we put the decimals in, we line up the decimals, and we have to make sure that we only add together like place values. So tens get added to tens, hundreds get added to hundreds, thousands to thousands, so forth. If I had $50 and I added $5, that doesn't mean I'm going to add the two fives together. No, because I'm lining up the place value. So make sure you do that. And check with your calculator. Make sure you're able to use calculator well. And add these two decimals up and make sure you get 307.629 or 307 and 629 thousandths. The rest is subtraction, which has the same rules. I'll make another video for that.